Okay, so this video is going to give you all the information you need for the final Greeble assignment. We did the very first part of the Greeble already, in which you had to create like groups of random sized boxes, and that you had to use a second randomized copy to create like random groups for each part. Now here it goes a little bit further in this assignment, and this is going to be the most difficult assignment you've gotten so far, because right here I'm going to leave a lot of open gaps that you will need and try to solve yourself this time. So the final result is going to be something as what you can see over here, in which you would have like a surface which starts from a very simple grid, as I can show you over here. So a very simple grid should become in the end something which is much more complex and which has a much more complex structure. So I will talk about the requirements, and I will show you some of the sub-elements that you need to solve. So I made over here like this whole set of things. So one of the first things is the division of the grid. So whenever you have a grid such as this, you need to make sure that each one of these polygons can be divided in a set of patterns. So either it says like a full division, or it has like one panel long and then two divisions over here, or it has like two panels, for example, or it is completely as this open square. So it's going to have like a lot of variations. Also the directions or the orientations can vary. So all of this should work, and that should not only work with square polygons, but it should work with all kinds of polygons. So if you're going to look over here at the division, this is some kind of a result of that. So you can see that each one of those primitives has been divided, and we have like all kinds of different division patterns, as you can see over here. So that's the very first step that you need to do. The second step, I'm going to put this to 0 at first, and the result that you see over here is just to give some variations later on. The second step is what you see over here. So two methods that we need in order to make sure that polygons are going to be changed or going to get like shapes such as these. I'm deliberately not saying exactly what you need to do, so you have to figure that out yourself as well. So they're going to have like an inset, and this inset can be big or small, and it has to be different for each polygon. Now if you look carefully, then you, or if you are going to examine carefully the tools you're going to work with, you should be able to solve this without using a for loop, and this is going to greatly increase the speed of the whole execution. This is a second method. This is one you need as well, and you need to be able to choose between both of those, which is practically the same, except that instead of just going in and going up at the same time, this version goes in two steps. It goes in on a horizontal level, and then it goes up a separate level. So both of these methods should be available. Now, depending on what you have a structure, and that's what I'm showing you over here, if you have like different sizes, you're gonna see by the standard method this is going to get a problem. So for example, if I make this geometry, if I take the smaller version of this geometry, you're gonna see that this is going to result into an effect that we don't want to have. Perhaps if I'm going to show you this version, it will be more clear. You see over here with like systems that still work, but the smaller they get, the more it gets corrupted, and you need to solve this as well. So I'm giving you a clue over here. You need to use a measure node, at a certain point, and what you need is that you need to be able to compensate the surface area. So as a result, you should get something which looks like this. So the smaller elements get, the smaller the effect is going to be of the method 1 or of the method 2. And so you can see over here, if I'm going to switch right here, then you're gonna see that it is still working proportion wise. So the proportions should be exactly the same. If you have like a big object coming in, or if you have like a small object coming in, the proportions should match up exactly. So try to figure out how you need to do that. And one of the things you need to do is on top of these primitives, so on top of these primitives and on top of these primitives, in the end you need to apply or need to place like a lot of small geometry like we see over here with all these kinds of variations. So make it as versatile as possible, and make it also procedural, the versatile geometry. And I'm going to give you an example of such versatile elements that you could create. So if you see over here, this is such an element I'm talking about, and as you can see, each frame is creating just like a random variation of that shape. And I'm not using booleans over here because that's going to be both very slow and also not reliable. So this is one of those elements, and so you have to create like lots of those, and again also think of small patterns to repeat and mirrored kind of effects that you can create just to give you the illusion of small machinery. Things such as that. So those are all elements you can think of. So enjoy yourself with this. I know from past that this is the most difficult one, and like I said, the reason is especially because right now you have to solve a lot of the elements yourself, but if you start accomplishing them step by step, you're probably gonna get really far. And once you solve this, you can start incorporating those elements into some other interesting parts. So for example, let's say over here is an example on how you can create these elements in combination with mirroring and also in combination with the rounded surface. Now this is not as easy as it looks at first glance, but if you think well enough about it, you might be able to solve this. But this allows you to create like really nice looking mechanical shapes. And in the end you can also combine this with more complex geometry structures. I have some more examples over here that I've created. So let me show these ones as well. So these generate like all kinds of pillars or systems which in fact could be placed inside of the Death Star or something like that. And so the idea is that you're going to use these kinds of Greeble functions as much as possible in combination also with your temple. So you're gonna create some kind of futuristic Atlantis-like temples with these systems we have over here. And another image I want to show you, and you can think of that on how it can be useful in the future, is this picture. And using the techniques you've seen so far, I think you can really well imagine how you can use a procedural technique in order to make a very complex scene such as this eventually. Okay, so this concludes the video on what you need to do for the final Greeble assignment.